All right, we are going to have a density quiz. I think it's important for you guys to learn how to do density. Here are the answers to the study guide that I gave you. Be sure that you know how to do all three of these problems and each part of the problem. Bear with me as I'm going to try to do math while trying to draw on an iPad, so sorry if it looks kind of messy. The first problem I want to know says, what is the density of this block? And the mass is 100 grams. Okay, so density equals mass over volume. That's what the formula is there. D equals M over V. I remember it because it makes a heart. If you use your imagination, if you connect the M and the V, it makes a heart. So let's see if we can figure out the density. Let's plug in these numbers. So density I do not know yet, so that stays the same. And then mass, remember the mass they told me it was 100 grams all over, and I don't know my volume. Okay, so that's what I know so far. Now I can figure out my volume. My volume is going to be, since this is a rectangle, my volume is going to be length times width times height. Okay, and I can plug that in. Volume equals the length right here, 12. That would actually be, this one does not have units, but remember you guys will always be working in centimeters, times the width, 4 centimeters, times the height, 3 centimeters. Okay, so now let's do the math. Volume equals 12 times 4 times 3. If you do the math, that equals 144 centimeters cubed. Remember, in volume we're talking about centimeters cubed, and that's because we do centimeters times centimeters times centimeters. That's how we get centimeters cubed. Okay, so we found the volume. Now we can go back up and we can plug in. So we knew that density equaled 100 divided by the volume. We had to figure out the volume. We now know that the is 144 centimeters cubed. So if you divide that, density equals 100 divided by 100 grams divided by 144 centimeters cubed. We get 0.69. And then our label is grams per centimeters cubed. Whoop. It's a terrible cubed. There we go. All right, so that would be our answer, would be 0.69 centimeters cubed. Let's go to the next one. The density of this block is 0.5 grams per centimeters cubed. What's the mass? Okay, let's write our formula again. Density equals mass divided by volume. In this one, I want to know, what is the mass? It says it here in the question. What is the mass? Okay, so I am no longer finding the density. I am finding the mass right here. Okay, so we need to solve this formula for mass. We need to solve this formula for mass. Here's how we can do that. We need to get M by itself. So let's first do that by undoing the volume here. So the volume's on the bottom. If I multiply by V over 1, or multiply by V, the v's cross out here, okay? But what you do to one side of an equation, you always have to do to the other. So I multiplied by volume on one side, I need to multiply by volume on the other side. So if I multiply by volume, I now have, for a new formula, volume times density equals mass. Okay, so that's my new formula. That's how I'm going to solve for mass. And then I just plug in my numbers. I already solved the volume in the last question. If you remember, this is the exact same cube. I tried to make it easy. The volume is 144 centimeters cubed. And then the density here, it's telling me, is 0.5 grams per centimeters cubed. So that's the times 0.5 grams per centimeters cubed, okay, equals m for the mass. Okay, now I know that mass is in grams, so I know that grams is going to end up being my final unit here, but what I need to do in order to solve the mass is I need to take 144 centimeters cubed times 0.5 grams per centimeters cubed. My answer ends up being 72 grams equals my mass. Okay, so the answer there for this entire problem, when asking for the mass, the answer is 72 grams. Let's look at the last one. So on this last one, it says with a density of 0.5 grams per centimeters cubed, what might this block be made of? And then would this block float? So it gave us the density. Here we have a chart. It's right here. You can see it's called the densities of solids. We have a couple of choices. It could be osminium, gold, iron, aluminum, sodium chloride, sugar, HD polyurethane, that would be high density polyurethane, wood, specifically pine wood, and then lithium. So those are our choices for the densities. These are all labeled in grams per milliliters, which is, we learned, grams per milliliters and grams per centimeters cubed. That's totally, they're compatible because they're both units of volume. So with a density of 0.5 grams per centimeters cubed, what might the block be made of? Well, with 0.5, if we're looking on here, it could be, I don't know, it's kind of close. You know, this one up here, osminium is 22.6. It's probably not going to be osminium. Sodium chloride is 2.16, getting closer. I think the answer is probably going to be lithium. No, the answer is not exact because lithium here is 0.53 and our density is 0.5, but I think that that's probably close enough. So the answer probably would be lithium. So to answer the first question, it's lithium. And then the last question wants to know, would this block float in water? If you don't remember, I believe in a previous activity I talked about how the density of water density is 1 gram per centimeter cubed. Okay, that's the density of water, or 1 gram per milliliter. It does not matter. It could be either, because those are compatible, so I could put either centimeters cubed or milliliter. If something floats, if you remember, something that would float in water means that it would have to have a density that is less. So that means the water's density would have to be more because it would have to keep whatever the object was. So if it's going to float, if this block is going to float, it has to be less than the density of water. If it's going to sink, then the density of this block must be more than the density of water. Okay? So that's our little rule of thumb there, and that works with anything. Okay, if something's going to float, that means it is less dense than whatever it's in. If something's going to sink, that means it's more dense than whatever it's in. So would this block float in water? Well, this block has a density of 0.5 grams per centimeters cubed, and water is 1 gram per milliliter. So just to write out our equality here, 0.5 is less than 1. So since 0.5 is less than 1, since it's less than water right here, it's probably going to float. Now in reality, lithium is probably not going to float in water, but in this example, yes, this block of lithium would float in water.